Dr. K. Senthilkumar, Assistant Professor, Department of Physics, Loganatha Narayanaswamy Government College, Ponneri, Chennai. He has done PhD in Material Science at Anna University, Chennai. He has 17 years of teaching experience. He has published 5 articles in national and international conferences and journals. He attended more than 14 conferences and workshops in all over India.
Welcome to UGC lecture series. Today's subject is quantum mechanics. Now, in this session, we are going to see some of the topics in quantum mechanics. So, objectives of this session is starting from quantum numbers. So, here we have 3 quantum numbers based on to explain the particle in a box in 3 dimensions. So, to explain 3 dimensions, 3 quantum numbers are required, namely principal quantum number, which explains the quantization of energy. Then second one, orbital quantum number, which illustrates quantization of angular momentum in terms of magnitude. Then the third one is magnetic quantum number, which also explains quantization of angular momentum, but in terms of direction. Now, let us see these quantum numbers one by one detailedly. The first one is basic quantum numbers. We know that quantum numbers are required to describe the electron in a hydrogen atom. Already in the previous sessions, we have seen quantum theory of hydrogen atom, in which we have expressed the wave function of a hydrogen atom is in terms of spherical polar coordinates. If we used to say it is spherical polar coordinates, then in terms of r, theta, phi. We know that r is the position vector, theta is zenith angle and phi is azimuth angle. So, based on these requirement, we will have to see these quantum numbers one by one. So, first one is the principal quantum number. So, we know that we have to express based on the separation of variables, the wave function of a hydrogen atom is equal to psi of r theta phi is equal to this r theta phi or represents spherical polar coordinates. So, we write in terms of functions. So, r of r, theta of theta, phi of phi. Based on these assumptions, then we have derived and deduced the equations for these 3 variables separately, namely equation for phi is d squared phi by d phi squared plus ml squared phi is equal to 0. Then equation for theta, 1 by sin theta d by d theta sin theta d theta by d theta plus L into L plus 1 minus ml squared by sin squared theta into theta is equal to 0. Similarly, we can have a equation for a radial part, that is equation for r. So, 1 by r squared d by dr, r squared dr by dr plus 2m by h cross squared into e squared by 4 pi epsilon naught r plus e into minus L into L plus 1 divided by r squared into r is equal to 0. So, each of these are an ordinary differential equation for a single function of a single variable, that is separately for r, theta and phi. Only the equation for r, that is the radial part, depends on the potential energy. The potential energy we know that we designate usually V or V of r. The equation for phi is d squared phi by d phi squared plus ml squared phi is equal to 0. So, result of this equation usually can be written as phi of phi is equal to a into e power I ml phi. So, this is denoted by the equation number 1. Then, so this picture indicates, we know this phi is azimuth angle in spherical polar coordinates. So, this value is phi. Then we know the angle of circle. So, for one full circle we will have 2 phi. So, this total angle is phi plus 2 phi. So, in spherical polar coordinate phi is a azimuth angle. Here additional circle we have, which angle is 2 phi. So, we have to replace phi plus 2 phi instead of phi. So, what we have seen in this picture, it is clear that phi and phi plus 2 phi both identify the same meridian plane. Hence, it must be true that phi of phi is equal to phi of phi plus 2 phi, or instead of phi plus 2 phi. So, we have got the equation a e power I m l phi is equal to a e power I m l phi plus 2 phi, which can happen only when m l is 0 or a positive or a negative integers. We know positive integer means plus 1 plus 2 plus 3 etc. Negative integer means minus 1 minus 1 minus 2 minus 3 etc. So, altogether if we say m l values 0 or plus or minus 1 plus or minus 2 plus or minus 3 etc. So, this constant m l is known as magnetic quantum number of the hydrogen atom. Then the second part, the differential equation for theta, that is we have taken as a function. So, theta of theta, capital theta of small theta, has a solution provided that the constant L is an integer equal to or greater than modulus of m l. Modulus means absolute value of m l. We know already, we have seen m l is a magnetic quantum number. So, this requirement can be expressed as a condition of m l in the form of m l is equal to, we have a condition plus or minus 1 plus or minus 2 plus or minus 3. So, here this constant small l is known as orbital quantum number. So, up to now m l is a magnetic quantum number, small l is orbital quantum number. Then the third part, radial part, the solution of the radial part R of r of the hydrogen atom wave function psi also requires certain conditions to be fulfilled. So, this condition is that E to be positive or have one of the negative values of E n, that is we can write the equation for this. So, E n is equal to minus m e power 4 32 pi squared epsilon naught squared h cross squared into 1 by n squared. So, E 1 by n squared. So, n varies from 1 to 3 etc. up to infinity. This is taken as equation number 2. We recognize that this is precisely the same formula for the energy levels of the hydrogen atom according to the Bohr. This is what Bohr obtained. Another condition is that must be obeyed in order to solve for the radial part R of r of the hydrogen atom is that n, that is n is known as principal quantum number, must be equal to or greater than L plus 1, that is n is greater than or equal to L plus 1. Already we know L is a orbital quantum number, m l is a magnetic quantum number. So, this requirement may be expressed as a condition of L is equal to 0, 1, 2 etc. up to n minus 1, where n is a principal quantum number. Hence, we may tabulate these 3 quantum numbers, that is principal quantum number, orbital quantum number and magnetic quantum number. Principal quantum number, it is designated by the letter n and varies from 1, 2, 3 etc. Then the second one is orbital quantum number, which is represented by the letter L. So, L is equal to 0, 1, 2, 3 etc. up to n minus 1. Here this n is principal quantum number. And third one is magnetic quantum number, which is represented by the letter m l. It is equal to 0 plus or minus 1 plus or minus 2 plus or minus 3 etc. So, it is worth noting again the natural way in which quantum numbers appear in quantum mechanical theories of particles trapped in a particular region of space. To exhibit dependence of this r, theta and phi on the quantum numbers n, l, m l, we may write for the electron wave function of the hydrogen atom psi. So, r theta phi is the spherical polar coordinates. So, these are all the quantum numbers. We couple this spherical polar coordinates in terms of these quantum numbers. So, the wave function of the hydrogen atom psi is equal to r n l, theta l m l and phi m l, which is denoted by equation 3. Now, let us see one by one in details what is principal quantum number. So, principal quantum number explains the quantization of energy. Already we have seen what is mean by quantization. Quantization means in terms of quantities we have to split up. So, quantization of energy level means discrete energy level, not a continuous energy level. So, that we are going to see in the principal quantum number. So, it is interesting to consider what the hydrogen atom quantum numbers signify in terms of classical model of the atom rather than quantum mechanical model of the atom. So, this model corresponds to planetary motion in the solar system, except that the inverse square force holding the electron to the nucleus is electrical rather than gravitational. We have to consider two quantities. So, these two quantities are conserved, that is maintain a constant value at all time in planetary motion, the scalar total energy and the vector angular momentum, that is energy in terms of scalar we know, then momentum in terms of vector, because momentum is a direction oriented, then energy is a magnitude oriented. So, we have only scalar quantities. So, classically the total energy can have any value whatever, but it must of course be negative if the planet is to be trapped permanently in the solar system. So, in this quantum theory of hydrogen atom, the electron energy is also a constant, but while it may have any positive value and negative values. So, these energies are quantized, that is E n is equal to E 1 by n squared, where n is the principal quantum number. So, based on this equation only we are saying energies are quantized. If n is equal to 1, then E n by 1, then n is equal to 2, E 1 by 4, n is equal to 3, E 1 by 9. So, we get discrete values of energies. So, this quantization of electron energy in the hydrogen atom is therefore described by the principal quantum number n. Then the second one is orbital quantum number. So, this illustrates the quantization of angular momentum in terms of magnitude. So, previously we have seen quantization of energy, now quantization of angular momentum in terms of magnitude. So, the interpretation of orbital quantum number L is less obvious. Let us look at the differential equation for the radial part R of R, what we have seen before, as we have taken from quantum theory of hydrogen atom. So, 1 by r square d by dr, r square dr by dr plus 2 m by h cross squared into E squared by 4 pi epsilon naught r plus E minus L into L plus 1 by r squared into r is equal to 0. This we consider as equation number 1, because we are starting from the orbital quantum number. So, this equation is concerned only with the radial aspect of the electron motion, that is its motion towards away from the nucleus. However, we notice the presence of E, that is energy, the total electron energy in the equation. The total energy E includes the electrons kinetic energy of orbital motion, which should have nothing to do with its radial motion. So, this contradiction may be removed by the following argument. The kinetic energy of the electrons has two parts, one is a radial part, another one is a orbital part. So, the potential energy of the electron is electrical energy, what we consider here. So, previously we have seen the potential energy. Now, we are going to replace the potential energy term in terms of electrical energy. So, that is given by, so V is equal to minus E squared by 4 pi epsilon naught r, this is equation number 2. Hence, the total energy of the electron is, so total energy is sum of the kinetic energy and potential energy. So, kinetic energy we have taken two concepts, one is radial motion, another one is orbital motion. So, in suffix we have indicated radial as well as orbital. So, kinetic energy radial plus kinetic energy orbital plus potential energy. So, here we have seen this potential energy we have taken as electrical energy, its value is minus E squared by 4 pi epsilon naught r. So, this equation rewritten like this. Inserting this expression for energy E in equation 1 we obtain after a slight rearrangement. So, 1 by r squared d by dr into r squared dr by dr plus 2 m by h cross squared kinetic energy radial plus kinetic energy orbital minus h cross squared L into L plus 1 divided by 2m r squared into r is equal to 0. If the last two terms in the square brackets of this equation cancel each other, what will happen? That means, in this square bracket these two terms are lost. If these two terms are considered is equal to 0, so kinetic energy orbital minus h cross squared L into L plus 1 divided by 2m r squared, if it is equal to 0, then we can equate these two. That is, kinetic energy orbital is equal to h cross squared into L plus 1 divided by 2m r squared. That means, we have seen this previous equation, we just equated this. Thus, the orbital kinetic energy of the electron and the magnitude of its angular momentum are given by kinetic energy orbital is equal to half mv orbital squared, then angular momentum L is equal to mv orbital. We may write for the orbital kinetic energy is Ke orbital, means kinetic energy orbital is equal to L squared by 2m r squared. Hence, from this equation we can write L squared by 2m r squared is equal to h cross squared into L plus 1 divided by 2m r squared. Then electron angular momentum capital L is equal to h cross into root of L into L plus 1. With the orbital quantum number L restricted to the values L is equal to 0, 1, 2, 3 etc. up to n minus 1. In macroscopic planetary motion, as in the case of energy, the quantum number describing the angular momentum is so large that the separation into discrete angular momentum state cannot be observed. For example, the electron whose orbital quantum number is 2 has the angular momentum, that is, if we consider the orbital quantum number is L. So, if L is equal to 2, so what we get, this is a total angular momentum. So, angular momentum is equal to this formula we have seen earlier. So, substitute L is equal to 2, we get h cross square root of 6. So, if you substitute h cross equal to h by 2 pi, where h is a Planck's constant, then we get a numerical value of 2.6 into 10 power minus 34 joule second. By the contrast of the orbital angular momentum of the earth is 2.7 into 10 power 40 joule second. Now, we can designate this angular momentum states. It is customary to specify electron angular momentum states by a letter with S corresponding to L is equal to 0, P up to L is equal to 1 and so on. According to the following scheme, we can say the angular momentum states. So, for L, if L is equal to 0, then S orbit, 1 P orbit, 2 D orbit, 3 F orbit. So, these are all the orbits in which only we will fill the electrons. This will we will have electronic configuration of the atoms. This table shows the atomic electron states. So, L here, then N here, N we know these are all the principal quantum numbers, L we know these are all the orbital quantum numbers. So, in order to specify one particular state, for example, if you want to specify this 2s state of electronic configuration, which will have the orbital quantum number is 0 and the principal quantum number 2. So, in this table what we have got from 1s state to 6h state. So, if you want to specify or explain this 6h state, then for 6h state, then orbital quantum number value is equal to 5 and the principal quantum number n is equal to 6. So, this peculiar code originated in the empirical classification of spectra into series called sharp, principal, diffuse and fundamental, which occurred before the theory of atom was developed. Thus, an S state is one with no angular momentum, a P state has the angular momentum and so on. We can explain like this. All these electronic states say for example, with the help of orbital quantum number as well as the principal quantum number. So, s orbit, p orbit, d orbit, f orbit, like that we have to go. So, based on these orbits only we will have a electronic configuration. Based on this electronic configuration only we can accommodate the electrons in the orbits around the nucleus. So, this combination of total quantum number with the letter that represents orbital angular momentum provides a convenient and widely used notation for atomic electronic states. In this notation, a state in which n is equal to 2, L is equal to 0 is a 2s state, for example, and one in which n is equal to 4, L is equal to 2 is a 4d state. So, that we have seen clearly in the table. Then the next one is magnetic quantum number. So, this explains the quantization of angular momentum in terms of direction. Previously what we have seen in terms of magnitude, now in terms of direction. The orbital quantum number L determines the magnitude L of the electron's angular momentum L. However, the angular momentum, like linear momentum, is a vector quantity, and to describe it completely means that its direction be specified as well as its magnitude. So, the magnetic quantum number ML specifies the direction of L by determining the component of L in the field direction. So, this phenomenon is often referred to as space quantization. If we let the magnetic field direction be parallel to the z axis, the component of L in this direction is space quantization, that is Lz is equal to ML into h cross. This ML we know, ML is a magnetic quantum number. So, ML values varies from 0 plus or minus 1 plus or minus 2 etc. up to plus or minus L, that we have seen already. So, the possible values of ML for a given value of L range from plus 1 through 0 to minus L. So, that the number of possible orientations of the angular momentum vector L in a magnetic field is 2L plus 1. When L is equal to 0, Lz can have only one single value of 0. When L is equal to 1, Lz may be h cross 0 or minus h cross. Similarly, when L is equal to 2, Lz may be 2 h cross, 0, minus h cross or minus 2 h cross, and so on. So, this is space quantization. For L is equal to 0 means then Lz value is 0. Then L is equal to 1 means Lz value is 0 plus h cross minus h cross. Then L is equal to 2 means then we will have 5 values, Lz is equal to 0 plus h cross plus 2 h cross. Then similarly this side minus h cross minus 2 h cross according to this equation. So, this is what explained earlier. So, the picture shows the space quantization of orbital angular momentum. Here the orbital quantum number is L is equal to 2, and there are according to 2L plus 1 we will have 5 values. So, what we have seen the 5 values, if L is equal to 2 means Lz is equal to 0 plus h cross plus 2 h cross, then negative side minus h cross minus 2 h cross. So, for orbital quantum number is 2, then the angular momentum in z direction, that will have 5 values according to the formula 2L plus 1. An atom with a certain value of ML, that is magnetic quantum number, will assume the corresponding orientation of its angular momentum L. So, what we infer from this, angular momentum capital L mainly depends on the magnetic quantum number ML. Though L is equal to ML into h cross is a constant value. So, the total angular momentum is equal to ML only, that is ML is a magnetic quantum number, that is what we have inferred from this. So, we note that L can never be aligned exactly parallel or anti-parallel to B, because it is always smaller than the magnitude of the total angular momentum. In the absence of an external magnetic field, the direction of the z axis is arbitrary. What must be true is that the component of L in any direction we choose is ml into h cross. For example, the line between the two hydrogen atom in the hydrogen molecule H2, simply we can write H. So, hydrogen molecule is just as experimentally meaningful as the direction of the magnetic field, and along this line the components of the angular momenta of the hydrogen atom are determined by their magnetic quantum number values, that is ml values. Next we will see uncertainty principle and space quantization. Why only one component of L is quantized? The answer is related to the fact that L can never be point in any specified direction, but instead of that it is somewhere on a cone in such that its projection is Lz is ml h cross. If the angular momentum L were fixed in space, that is Lx, Ly as well as Lz had definite values, the electron would be confined to a definite plane. For instance, if L were in the z direction, the electron would have to be in the xy plane at all times. Then L is in z direction, so electron is confined in this xy plane. So, del z represents uncertainty. This we have already seen in the uncertainty principle. Suppose then the direction, this L is in z direction here. Suppose this L is in another some other direction rather than this z direction, then we will have a plane like this. So, the electron present in this plane also changes. So, what is the comparison between these two diagrams? In z direction means the electron present in this xy plane, whereas the direction is changes rather than this z direction either of left hand side or of right hand side, then the electron presenting plane will be automatically changed. So, this can occur only if the electron's momentum component p in the z direction is infinitely uncertain, which of course is possible if it is to be a part of the hydrogen atom. However, since in reality only one component Lz of L together with its magnitude L have a definite values, modulus L is greater than modulus Lz, the electron is not limited to a single plane. Thus, there is a built-in uncertainty in the electron's z coordinate. The direction of L is not fixed as in the picture, and so the average values of Lx, Ly are 0, although L always has the specific value. So, this diagram explains the angular momentum vector L precedes the constantly about the z axis. What is the meaning of precedes? So, this is z axis. So, this angular momentum of the electron in the hydrogen atom rotates always about this z axis. That is what we are using the word precedes. Now, let us summarize what are the topics we have seen in this session. Starting from the quantum numbers, we have derived the quantum numbers based on the quantum theory of hydrogen atoms as well as variations, that is separation variables or theta phi. So, different quantum numbers we have seen, principal quantum numbers, explained quantization of energy. Then we have seen orbital quantum number, which illustrated the quantization of angular momentum in terms of magnitude. Then the last one is magnetic quantum number, which also explains the quantization of angular momentum, but in terms of directions. Now, let us see what are the questions can be asked from this session. Why 3 quantum numbers are needed to describe an atomic electron? Then compare the angular momentum of a ground state electron in the Bohr model of the hydrogen atom with its value in the quantum theory. Then what are the angles between L and z axis for the orbital quantum number L is equal to 1 and L is equal to 2. Then last question, list the sets of quantum numbers possible for the principal quantum number n is equal to 4, for the hydrogen atom. The rest of the topics we will see in the future sessions. Thank you.